Hello students, welcome to MAGESH classes. This presentation consists of 11th standard chemistry book back questions from 16 to 30 with detailed explanation. And the part 1 consists of question from 1 to 15 explanation. Here all the questions have been discussed in the clear way. I hope that it will be useful to you. Let us move into the video part. Question number 16. The KH for the solution of oxygen dissolved in water is 4 into 10 raised to 4 atmospheric pressure at a given temperature. If the partial pressure of the oxygen is in air is 0.4 atmosphere, the mole fraction of oxygen is the given quantity KH is equal to 4 into 10 power 4 atmosphere. And the partial pressure of oxygen in air is equal to 0.4 and mole fraction of the oxygen. The formula is partial pressure of oxygen is equal to Henry constant into mole fraction of the oxygen. The partial pressure of the oxygen is given, it is 0.4. The Henry constant is given 4 into 10 to the power 4 and the mole fraction of oxygen. The mole fraction of oxygen is equal to 0.4 divided by 4 into 10 to the power 4. This is equal to 1 by 10 into 10 to the power 4 or 10 to the power minus 5. Our answer is D. Here the C and D. Here it is 10 to the power plus 5 and the minus 5. Answer is C. Question number 17. The normality of 1.25 m sulfuric acid is. The normality of the acid is equal to molarity into its basicity. That is number of replaceable hydrogen atom. So normality is equal to, molarity is given, that is 1.25 m into sulfuric acid. What is the replaceable hydrogen atom? It ion is to give 2H plus and sulfate ion. So it is 2. So normality is equal to 1.25 into 2. It is 2.5. Yeah, the answer is C. Question number 18. The two liquids X and Y on mixing gives a warm solution. This solution is ideal, non-ideal, ideal, non-ideal. For an ideal solution, when two solutions are mixing, the del H is equal to 0 for the ideal solution. For non-ideal solution only, the temperature vary when the solutions are mixed. Here it gives warm solution, that is delta H, so it is exothermic reaction. Delta H is negative. We know that delta H is 0 for ideal solution. When delta H is positive, it shows positive deviation from the ideal solution, and delta H is negative, it shows negative deviations from ideal solution. So here del H is a negative. So our answer is ideal, non-ideal and shows positive deviation, non-ideal and shows negative deviation. So your answer is D. Question number 19. The relative lowering of vapor pressure of sugar solution in water is 3.5 into 10 power minus 3. The mole fraction of water in that solution is. In the sugar solution, sugar is the solute and water is the solvent. The mole fraction of sugar is said to be X2 and the mole fraction of the solvent is said to be X1. According to Raoult's law, The relative lowering of vapor pressure, that is del P by P naught, is equal to mole fraction of the solute. Okay. In the problem, the mole fraction of water in the solution is asked. So x2 is equal to 3.5 into 10 power minus 3. Then x1, that is mole fraction of water, is equal to 1 minus x2. So this is equal to 1 minus 3.5 into 10 power minus 3. So this is equal to 1 minus 3.5 into 10 power minus 3. 3.5 10 power minus 3 is written as 0.0035. By subtracting, it will be 5, 6, 9, 9. So our answer is 0.9965. According to Raoult's law, the mole fraction of the solute is equal to relative lowering of vapor pressure. The sugar solution, it is given. The mole fraction of water is in the question. So you have to subtract from this value from 1, because the x1 plus x2 is equal to 1. Our answer is 0.9965. D. Question number 20. The mass of a non-volatile solute, the molecular mass is 80 gram mole inverse, which should be dissolved in 92 gram of toluene to reduce its vapor pressure to 90%. What is the given quantity? The solvent is toluene. The molar mass of the solvent is equal to, it is 72 plus 5 into 1, 5 plus 112 plus 3. So it is a molar mass of the carbon, 72, 77, 80, 92 M1. And W1 also given, it is 92 gram. Molecular mass of the solute, that is M2, is 80 gram mole inverse. And weight of the solute is in the question. And relative lowering of vapor pressure, that is the vapor pressure of the solution, is given. That is P naught, vapor pressure of the solvent, minus vapor pressure of the solution upon vapor pressure of the solvent. It is said to be relative lowering vapor pressure is equal to mole fraction of the solute. Here the P naught is 100 minus 90 upon 100. So this is equal to 10 by, or 100 by 10 is equal to N1 plus N2 by N2. So this is equal to 10 is equal to N1 by N2 plus N2 by N2. It will be 10 is equal to N1 by N2 plus 1, or N1 by N2 is equal to 10 minus 1, this is equal to 9. It is W1 by M1 into M2 by W2 is equal to 9. So W1 is equal to 92. M1 also it is 92. M2 is 80. W2 is in question. This will be 1 into 80 by W2 is equal to 9. So this is equal to W2 is equal to 80.9. This will be 8.89 gram. Our answer is D. For a solution, the plot of osmotic pressure versus the concentration gives a straight line with slope 310 R. Where R is the gas constant, the temperature at which the osmotic pressure measured is. Osmotic pressure pi is equal to concentration into R into T. It is a linear equation as in the form of y is equal to mx. In the graphical format, in the y-axis, the osmotic pressure is plotted, and in the x-axis, the concentration is given. So RT is the value of M. So it gives a straight line, gives a slope, that is, this slope is equal to this M value. So M is equal to, the slope M is given, it is 310 R. So 310 R is equal to R into T. So T is equal to 310 Kelvin. So in the Celsius form, it is 37 degrees Celsius. Because the Celsius is obtained by 310 minus 273. 300 Kelvin minus 273, it will be 37 degrees Celsius. Our answer is C. Question number 22. 200 ml of an aqueous solution of a protein contains 1.26 gram of protein. At 300 Kelvin, the osmotic pressure of this solution is found to be 2.52 in 10 power minus 3 bar. The molar mass of the protein will be. The osmotic pressure, weight of the protein, and volume of the solutions are given. Molecular mass of the protein will be questions. The given data are. The given data, volume of the solution is 200 ml, it is 0.2 liter. Weight of the protein W2, it is 1.26 gram. And the temperature 300 Kelvin. Osmotic pressure pi is equal to 2.52 in 10 power minus 3 bar. And R is equal to 0.083 liter bar mole inverse Kelvin inverse. And what is the molecular mass? The collocative property osmotic pressure is related to the concentration in molarity by the equation Y is equal to CRT. Here C is the molarity. It is nothing, number of moles of the solute upon volume of the solution in liter. This equation can be written as N2V into RT. N2 is nothing, it is number of moles, number of weight of the substance divided by molecular mass of the substance. So this can be expanded as W2 by M2 into V into R into T. So the required equation is M2 is equal to W2 into R into T divided by pi into V. By substitution, W2 is equal to 1.26 gram into R is equal to 0.083 liter bar mole inverse Kelvin inverse and temperature 300 Kelvin divided by pi, it is 2.52 into 10 power minus 3 bar into volume 0.2 liter. By cancelling this, it will be 2. This is equal to 0.083 into 300 upon 2 into 10 power minus 3 into 0.2. The unit cancel is liter, liter, bar, bar. This Kelvin and that Kelvin. So only the gram mole is inverse one is there. This is equal to 83 into 10 power minus 3 into 300 divided by 2 into 10 power minus 3 into 2 into 10 power minus 1. This minus 3 is cancelled. So it will be 300 into 83. 900 divided by 4 into 10 power minus 1. This will be 2,49,000 upon 4. So this is equal to 66,222 gram, or it is 66.22 kg. So your answer is A. 23. The Van Hoff factor I for a dilute aqueous solution of strong electrolyte, that is barium hydroxide, is. The required formula is alpha is equal to I minus 1 by N minus 1 for dissociation. So I is the Van Hoff factor, alpha is the degree of dissociation, N is the number of ions. Alpha is the degree of dissociation. N is equal to number of ions. By substituting, what do you get? This alpha into n minus 1 is equal to I minus 1. Alpha for the strong electrolyte is equal to 1. So 1 into, what is N value? It is barium hydroxide. Barium hydroxide is dissociate to give Ba2 plus and 2 OH minus ion. So totally 3 ions are present. Minus 1 is equal to I minus 1. So it will be 1 into 2 is equal to I minus 1. So I is equal to 2 plus 1. This is equal to 3. The answer is D. Question number 24. What is the molality of a 10% W bar W, that is weight bar weight, aqueous sodium hydroxide solution is? What is the molality? The molality is given by the formula number of moles of the solute upon the weight of the solvent in kg. So N2 can be expanded as W2 by N2, the weight of the substance by molecular mass, and this W1 into kg. So the given data consists of only the sodium hydroxide is a species. Sodium hydroxide molecular mass is 40. And the weight of the solvent and weight of the substance is in the form of 10% W bar W. 10% W bar W means 10 gram of sodium hydroxide is dissolved in 100 gram of water. Okay. So weight of the sodium hydroxide, that is W2 is equal to 100, and weight of the water, it is W1, is in kg. It is 100 gram. So M is equal to, what is W2? W2 is 10, M2 is 40, and weight of the water in kg, it is 0.1. So this is equal to 10 divided by 40 into 0.1. This is equal to 4. It's equal to 2.5 molar. Your answer is B. 25. The correct equation for the degree of an associated solute, n molecules of which undergoes association in solution. Colligative properties and the Van Hoff factor is related as I is equal to n minus 1. If the solute particles are electrolyte, it may undergo dissociation or association, so that the colligative properties observed is greater than that of the greater, or it is less than that of the colligative properties calculated. If it is dissociate, the colligative properties observed is greater than that of the calculated properties. And in the case of association, it is reverse. Because the molecules combine together, so the number of colligative properties is less. So colligative properties observed is less than that of the colligative properties calculated. The Van Hoff related this to the degree of dissociation or association, that is alpha is equal to I minus 1 divided by n minus 1 for the dissociation. Alpha is the degree of dissociation, I is the Van Hoff factor. If the molecule is associated, here it is dissociated, it is alpha D associated, what happens? It is reversed. The reverse is nothing, it will be I minus 1 into n. Here it is inverse, and so it is 1 minus n. Okay, so this is the basic difference. The number of the denominator, it is n minus 1. In case of association, it will be 1 minus n. In 1 n is added. So here the problem, the associating molecule. So associating molecule, the alpha is equal to I minus 1 divided by 1 minus n. So here the denominator is different. So A is not answer. Here it is n minus 1. Here here it is reverse, but here the alpha squared is given, it is wrong. So I minus 1, it is the answer. Question number 26. Which of the following aqueous solutions has the highest boiling point? Here the different same concentrated solutions are given. Which one has highest boiling point? The concept is, as the number of ions in the solutions increases, the elevation in boiling point also increases. So in case of option A, the potassium nitrate dissociate to give K plus and NO3 minus ion. So number of ions 2. The B option, the sodium phosphate dissociate to give 3 Na plus and 1 phosphate ion. So number of ions are 4. In barium chloride, ionize to give barium 2 plus and 2 Cl minus ion. So it will be 3. In potassium sulfate, it ionize to give 2 K plus and 1 sulfate ion. So totally 3. The number of ions is maximum in the B option, that is sodium phosphate. So this shows highest boiling point. Question number 27. The freezing point depression constant for water is 1.86 Kelvin kg mole inverse. If 5 gram of sodium sulfate is dissolved in 45 gram of water, the depression in freezing point is 3.64 degrees Celsius, the Van der Waals factor for the sodium sulfate. When sodium sulfate is dissolved, what happens? The freezing point of water is decreased. And from the decreased value, you can calculate the molecular mass and Van der Waals factor. The Van der Waals factor and colligative properties are related as this: delta TF is equal to I into KF into M. This equation can be expanded as delta TF is equal to I into KF into number of moles of solute divided by molality, so weight of the solvent in kg. So this is equal to I into Kf into W2 by M2 into W1 into kg. This is delta TF. Delta TF is 3.64 and I is in the question, and Kf is equal to 1.86 into W2. W2 is 5 gram and molecular mass of sodium sulfate Na2SO4 is equal to into 23 plus sulfur 32. It is 4 into 16. Oxygen 16. Sulfur molar mass 32. Sodium molar mass 23. This is equal to 142. So it is 142 and W1. W1 is nothing. It is the weight of the solvent, 45 gram. So in kg it is 45 into 10 power minus 3. To find I is equal to 3.64 into 142 into 45 into 10 power minus 3 upon 1.86 into 5. So this can be cancelled as, it will be 1.95 and 955 into 5 cancel as 9. And this is equal to 1.95 into 142 into 9 into 10 power minus 3. This is equal to 1.95 into 9, 45, 4, 81, 85, 8, 72. 72.55. 72.55 into 142 into 10 power minus 3. By multiplying this, you will get 2.50. This minus 3. Your answer is A. Question number 28. The equimolar aqueous solutions of NaCl and KCl are prepared. If the freezing point of the NaCl is minus 2 degrees Celsius, the freezing point of KCl solution is expected to be. Here the two solutions are NaCl and KCl, both are having the same concentration. And the colligative properties in the freezing point of the NaCl is minus 2 degrees Celsius. And what is the freezing point of the KCl? KCl is also minus 2 degrees Celsius because NaCl dissociate to give the two ions Na plus and Cl minus ion. KCl dissociate to give K plus and Cl minus ion. Both are having same number of ions, 2, 2. The colligative properties depends upon the number of ions. So we can expect the freezing point of KCl also be minus 2 degrees Celsius. Question number 29. The phenol dimerases in benzene having 1 power factor 0.54. What is the degree of association? If the electrolytes are associated, the degree of dissociation is given by the formula alpha is equal to I minus 1 divided by 1 minus n. So this is a formula. Here what is the degree of association? So alpha is equal to I minus 1. What is I? The 1 power factor is 0.54 minus 1 and the number of ions. Phenol dimerases and number of ions are 2 divided by 1 minus 2. So this is equal to minus 0.46 into 2 divided by minus 1. This is equal to 0.92. Your answer is D. Question number 30. The assertion an ideal solution obeys Raoult's law, and the reason in all ideal solutions the solvent-solvent as well as the solute-solute interactions are similar to the solute-solvent interactions. First of all, assertion an ideal solution obeys Raoult's law. So it is a correct statement. So the assertion is correct. The Raoult's law is nothing. The relative lowering of vapor pressure of the solution is equal to the mole fraction of the solute. So assertion is correct. And the reason, an ideal solution solvent-solvent as well as solute-solute interactions are similar to the solute-solvent interaction. The solute-solvent in the interaction is in the solution, and the solvent-solvent interaction in the solvent and the solute interactions in the solute species are similar in case of ideal solution. In non-ideal solution, the solvent-solute interaction is either greater or less than that of the solvent-solvent or the solute-solute interaction, so that it deviates from the ideal behavior. So the reason is correct. So both answer, assertion and reason are true, and the reason is correct expression of the assertion. Okay students, this is the end of our presentation. I hope that it is useful to you. Thank you for watching.